We've talked now about the parts of the brain, a little bit about what the different parts do. And let's end by talking about the brain as a whole. So if you just look at the brain, if you remove it from somebody's head and put it on your table, it looks symmetrical. But it's actually not. And so this final topic is about what's called lateralization, which is about the difference between the two halves of the brain, the right half and the left half. It's long been known that there's a difference between right and left. We're not symmetrical creatures. Most people are right-handed, meaning that they do a lot of their motor control and they're most fluid and capable, like right handwriting, with their right hand. And a minority of people are left-handed. And then some people are evenly mixed, ambidextrous, right and left. People who are right-handed, for the most part, have language in the left half of their brain. And people who are left-handed are more evenly mixed. Some people have in the right side of their brain, others in the left side of their brain. So the cool thing is that most functions of your brain are duplicated. So a lot of times when you hear somebody say, oh, the right side of the brain, the left side of the brain, and right-brained and left-brained, a lot of what people say about that is total nonsense. Most of the functions of the brain are on both sides, and to a large extent, it's sort of more of an issue of dominance or greater potential in one side than another than an absolute difference. But as the sort of common wisdom goes, the left brain is more associated with written language and spoken language, with reasoning and logic and science. And the right brain is more associated with insight and imagination and music. So we have these two halves of the brain. And normally they're in coordination. But they deal with the world in different ways. So one thing worth noting in any discussion of the halves of the brain is that it works on a principle of contralateral organization, which is an awful technical term, but what it means is that your right brain sees the left side of the world, the left visual field, and the left brain sees the right side of the world. It just works out that the brain has this crossover effect where each half of the brain is looking towards the opposite half of the world. And similarly for motor control, your right hemisphere controls the left side of the body, your left hemisphere controls the right side of the body. Now, you might say, well, this is ridiculous because I'm one person. I'm not two people. I can understand language and appreciate art. I see the world as a coherent scene. I don't see the world with half of me and see the other half of the world with the other half of me. But that's because the two halves of the brain are in constant, immediate conversation. It's through the corpus callosum. And the corpus callosum is a network of neurons that connect one half of the brain with the other half. And this is what allows sensory information that's received on the left side of the brain, for instance, to be appreciated from the right side of the brain. It's what allows the left side of the brain to control the motor actions on the right side of the body because it could send instructions over to the right side of the brain to do it. In fact, you can see in some clever experiments the strange organization of the brain. So for instance, if you flash on a screen very quickly something on the right side of the body, you're quicker to name it than if it's flashed on the left side of the body. Well, why would that be? Well, think about it. If it's flashed on the right side of the body, it's immediately perceived by the left hemisphere. The left hemisphere is where spoken language is. So you say, oh, it's a cup, it's an apple. If it's flashed on the left side of the body, for a fraction of an instant's delay, it has to cross over to the left side of the brain. And you'll never see this in everyday life. The time differences are just too small. But in the psychology lab, you can see this. Now, what becomes really interesting is that for almost everybody, the two halves of the brain are in constant conversation. But not everybody. So a while ago, people with severe epilepsy, they would cut the corpus callosum. Epilepsy could be viewed as an electrical storm in the brain. The corpus callosum causes the brain to communicate from one half to another. So cutting the corpus callosum in some way, the idea would be that it would isolate and shrink the electrical storms. And so people did work on that, where they did this very severe form of surgery on people with terrible cases of epilepsy. And And the consequence, which they didn't anticipate, is all of a sudden you break one person off into two to some extent. You have a left side of the brain, which does the talking, and a right side of the brain, which does a lot of other things, which appreciates music and space and so on. And the idea is that in some sense, you've taken a person and now you have two, one half of them who can speak and articulate their wishes, the other that can't. And making sense of this, what this means, what this does to a person, leads to philosophical questions that fall outside the scope of this course.